Hello, we're back with part 4 of the Menace Amiga Format series, and I've started with the GitHub because just to let you know that I have put the stuff that I've done in GitHub. I did that last time, but it's just in case anybody didn't know it's here. And I'm going to start by looking at this because I've got easy links to all the articles that came in Amiga Format, and there is one of the covers for it. I did have that issue and I got rid of it back in the day. Bit of a shame. There's the code we've got working. Oh yeah, and there's the header from one of the articles. So actually these links here, just to let you know, do actually go to a PDF that's got the actual article in from each issue, and I've just cut out those sections so they're quite easy to read. So when we left it last time, well, we fixed the graphical corruption here. Yeah, so by the end I've got it working, but we've got some graphical corruption, and you can see that the collision detection on the missiles isn't working, but the collision detection on the ship is working. So the ship is actually a sprite, and the collision on that is working. You don't get collision on the background in this unless you're in expert mode, and I don't think that's enabled in the demo, but we could turn it on. And the collision with the enemies is what is taking the shield down. So that is working, but the collision with the missiles is just not working at all. So I thought we'd start by reading the article, because this one, part 5 collision detection, issue 12, issue 12 of Amiga Format, does actually cover, if you just click that in GitHub here, it will actually just open up. There's the front cover. And here we are, the whole truth about games programming, part 5, collision detection. The Menace code is nearly complete, becoming playable as Dave Jones adds bump into things routines. And they just put a picture of these spaceships on, which seem to have very little to do with the game, but they must have had some stock art. The Batman pack was £349. Here we go. So he starts talking about the collision detection, and yeah, so ship to foreground, we won't read that now because that is actually working, but basically that is sprite detection with the foreground plane. It's dual bit plane mode. It does say I register collision between planes 2, 4, and 6. So I think the two play fields, is even bit planes and odd bit planes for the two play fields. Okay, so ship missiles are drawn into the foreground play field, and the enemies are drawn into the background playfield, and that probably explains why when we saw the graphical corruption last time, if I go and have a look, you can see that some of the corruption is on the foreground playfield and some of it's on the background because it's moving at different rates. So you can see that that enemy there is definitely corrupting the background playfield because you can see the yellow appearing in the background, and then something there is being corrupting the foreground. So both playfields are getting corrupted, but then different things are being drawn into different playfields. So there's a thing of note. So the last part of the collision detection is missiles to aliens must be able to determine what particular missile hit what particular alien. This must be implemented using some form of coordinate checking. Here we go. This is the second main way to perform collision detection. Between the missile, that's the missile there, and that's an alien, I think, or is that one of the missiles from the... That's one of the missiles from the actual Guardian, but it's classed as an alien, I think. Coordinate checking can never be pixel perfect unless we checked every pixel coordinate in the missile against every pixel in an alien, which will require huge amounts of time and cause a grain to coral line. Okay, because remember, back in the day here, you didn't have a lot of processing power, so doing something like that would be out of the question. What normally happens is a box is defined with the two objects you're checking. A box needs only two coordinates, the top left and bottom right. If the two boxes overlap, then we flag a collision. So that makes sense, and we still do that in games nowadays. You can see this is quite a rough box in that not many aliens appear as a box shape. Yeah, that is your problem with the box, is if your alien doesn't fit in the box, then that's rubbish. But in this case, that alien would fit in a smaller box, so I suppose that's the box they've defined for... Why is it defined that big? I don't know. Oh, it's actually going to say that in a minute. In Menace, missiles are quite small, so rather than define a box for each missile, only one coordinate at the tip of each missile was checked. So just checking that coordinate there. If this coordinate entered the box of any alien, then a hit was registered. So that coordinate there is inside this box, so it registers a hit. But as you can see here, this box is much bigger than the alien, so this one would hit that, even though really it should go right past it if these two are going in straight lines. It says, I made all the alien collision boxes 32 by 24 pixels in size. Exactly the same as the alien size. What's the alien? So I don't know what it's saying there. Oh, is that the alien size that it's drawing, maybe? This would appear to cause a problem if the alien was quite small in size. So he's saying that these boxes he's registered is always one size for every alien, even if the alien is a bit smaller. Yeah, this would appear to cause problems if the alien was quite small, not filling the entire box. Have a look at figure 2. Figure 2, it says it there. This is done in DPaint, isn't it? This shows a small alien with a missile entering the box, flagging a collision. But as you see, it would not want this particular case to flag, which is what I just said, actually. Any collision as the missile, we would not want to flag any collision as the missile is quite far away from the actual alien itself. That's what I just said. I just preempted the article there, didn't I? One way around this would be to store a collision box size for each alien. Yeah, you could do that, because that would fit in a little box like that. That would fit in a box. The one in figure 2, for example, would suit a better box of 24 by 18 would be better. This makes the calculation of whether the missile was in the box or not more lengthy. Though as we are not dealing with constant numbers, this may seem picky, but if we have 12 aliens flying around, and as you can have up to 18 different missiles active at once, missiles, lasers, cannons, etc., this would mean checking every missile against every alien equals 216 checks. It's funny to talk about something like 216 checks as being a lot, because back in the day, these computers weren't that fast. But nowadays, your computer would whiz through this. You'd be like, 216 checks? I'll do it, no problem. Back in the day, though, that would be too much. You've wasted too much of your frame on that stuff. This will be quite a time-consuming, as there's a fair bit of calculation in each check. 216 box checks. Can you even imagine doing that? It's crazy. So what's this? Make it simpler. What we need is a quick way to tell if any missile has hit any alien. If this happens, then we can check for which alien it has hit. Fear not, for this is quite simple to do. Oh, fear not. What we need to do is combine the mass detection with the coordinate detection. We cannot use the Amiga's hardware detection for missiles to aliens, as this only works with hardware sprites. So that's what the ship's using. The Blitter can do a quick check for us, though. The Blitter has a bit called B0 in the DMA ConR register. So that's DMA control read register. This bit will be set to true if the result of the previous blit operation is all zeros. We therefore get the Blitter to perform an AND operation between the mask of the missile and plane 5, which only contains data from the aliens. So yeah, is it the foreground? It's the background plane has got 3 planes, but the aliens only write into plane 5 just because of the colours they're using, I think. So the background itself won't have anything in that bit plane. It's quite clever, really, that it's using the bit planes to do all this. If the B0 comes back false, i.e. the result of the blit was not 0, then the missile must have collided with some alien data. So it's just checking that if you combine this little picture here with that plane 5, it's checking to see if something is there. And then now we can perform the coordinate detection to find out which alien we hit. Yeah, because that only tells you that you detected something in plane 5, but it doesn't tell you what it is, because that data is just the color data, and all the aliens can be the same color. So this also solves the problem in figure 2, which would not now flag a collision because the mass detection would not flag a hit. So therefore the coordinate detection would not be then performed. We then perform the blit to AND the mask with plane 5. We switch off the destination channel. So when you're actually kind of like doing a blit to a channel, but the channel isn't enabled, so it doesn't change anything. We do not want the Blitter to draw a result of the blit, so it's pointless to have any area of memory point to the D channel. It's quicker, therefore, more efficient to switch off the destination channel for this blit. This is a handy feature of the Blitter, allowing us to combine a few channels in some way, but only interested in whether the result was 0 or not. This method of performing the missile to alien collision will be considerably faster, even taking into account the Blitter operation. On average, only 3 out of 18 missiles would actually be hitting aliens. This reduces the coordinate checking to a lower level, only 3 times 12, 36 comparisons. So he's doing a combination of the Blitter pixel perfect check to check if that has hit this, and then if it detects a collision, then it looks to see if it's in that box and goes, well, I know which alien it was now. It's the one that's in that box. So that's pretty cool. It's interesting, though, because by upgrading this to AGA or the Amiga 1200, this stuff isn't necessarily true anymore, that doing those 216 checks is actually slower anymore, because it might not be on a 68 or 20, because you can probably, well, if you had some fast memory as well, you might be able to rip through those checks pretty quickly, and it's got an instruction cache as well, so you can go through loops quite quickly. So there's a very good chance that it's possible that is actually quicker, and it might be the reason that this game isn't working correctly right now. We'll look at that in a minute, because there were some suggestions from last week, and we're going to take a look at that. It says that then is the collision required in Menace. Ships to aliens, ships to foreground, ships to alien, missiles to aliens. That's what we've looked at. There are 4 different types of missiles: normal missile, cannon, laser, and outrider. all have different ranges and speeds, and they all subtract 1 from an alien's hit number. But lasers are not killed once an alien is hit. They then carry off to the end of the screen. Graphically, they're quite small, 16 by 4 pixels, and are just 4 colour. The blitter is used to draw them to plane 2 and 4. Weapons in shoot-em-ups nowadays are getting big. If you plan on trying to write one, I would say the bigger the weapons, the better for mega effects. There should be no difference in the collision detection, only the extra time taken to draw the bigger, better weapons. So that's a pretty cool explanation of what's actually going on here. If we look at the comments from last time, there was a couple of suggestions by people about what could be going wrong with the game, basically, because we've got corruption and we've got missing collision detection. And now we know that the collision is being done by the blitter. That might explain things, because we've got graphics going wrong which are being drawn with the blitter, and we've got collision detection going wrong which is being done by the blitter. So we've definitely got blitty problems going on here. Anyway, suggestions were, David Lloyd says, Amiga ABI, is that application binary interface, assumes that D2 to D7 and A2 to A7 are preserved on a JSR. That's a jump to subroutine. It's good practice to move those registers to the stack. Move M. What's move M? Moves the contents of selected registers to or from consecutive memory locations, starting at a location specified by the effective address. Oh, so you can do a load of registers at once. I didn't know you could do that. So I've forgotten on my 68,000. So move M can move a load of registers at once. I didn't know that one. Here we go. Darren Cole, 8857, says, graphics issues could be lack of blitter weights. Just speculating, but it was common just to assume that the blitz would complete, but you are running a faster CPU. That might well not be the case. That, I think, could be the winning suggestion here, because not only is this running on an 68020, which is double the speed and has an instruction cache, but also I'm emulating with 4 megabytes of fast RAM, because my Amiga's got fast RAM. And if the code is running out of fast RAM, it also doesn't have to wait if chip RAM is being accessed. So it can go faster, faster, and faster. So actually, you know, this isn't just a double speed CPU, the 6820 in this case. Because of the fast RAM, it's going a heck of a lot quicker. But that could indicate the problem with the collision detection and why we're getting corruption on the graphics as well, because blitter operations are being stomped over by a subsequent blitter operation, because the code afterwards is running so quickly, which wouldn't have happened on the 68,000. Well, probably wouldn't have happened. Here we go. Jamie Orlando says, for the graphical corruption, did you try disabling CPU caches? Maybe that would have an effect. That is quite possible that would, because you basically, what you're doing is you're nerfing the CPU to try and get rid of that cache to make it go slower to make the blitz work. But the whole point of this series that I'm doing is that we are going to look at the code and try and fix the code. We're not going to try and change the machine. We're going to try and change the code to work on the machine. And I think that's the point here. But yes, that might actually work. And if it did, it might tell us that, you know, that's our problem, that the blitter weights aren't there. Because this code definitely works on a stock A500, or at least on the emulator on stock for A500. And as soon as you upgrade to 6820, it just, bang, it's gone. Yeah, my money's on the blitter weights. So we're going to test that out first. So let's just go and take a look at the code and see if we can locate any of this code that they're talking about. I have been looking at a little bit of this offline just so I can get my head around what's going on. Where's the main loop? Yeah, so update missiles is where I think the check collision, you'd think it would be in check collision, but that's the ship collision. It's not actually in that one. It's in update missiles. So I've been going through a bit of this. I haven't figured it all out yet, but basically there's a few things going on here. This first section, they are checking for, there's a fire delay of 3 frames, so it just decrements the fire delay down to 0 there and stops at 0. So that's part of the update. This missile table, I don't know what that's all about, but basically there's a data structure. I think it might have the mask in it or something like that. But they are basically trying to figure out an offset for something in that table. And then we go down here. D3 here, this size for cannon, this is the blitter size. And the blitter size is encoded as, I think it's 4 bits and 6 bits. That's the size for the next blitter operation that's going to be done, which is going to, it says update missiles, but it's actually going to render them, I think. So that's the size for the blitter operation, and it's encoded as 4 bits at the bottom and 6 bits at the top for the width and height. I think it's the widths in words and the heights in lines or something. I can't remember now. I'd have to look that up. And I think it's doing different kinds of missiles. So it's check cannons first. What's it doing there? Check range. It's dead. Move 8 pixels. Is it off screen? Right. Draw the missile. So it draws it there. Let's find draw missile. So here we go. So it's saving something on the stack. Missile sprite. So it's setting up a blit here basically. D5, D6 is the foreground buffer. It's setting up the modulos to the blitter, the pointers to the bit planes. That's the, what do they call it? The min term they call it for the blitter, which is D equals A and B not C. So with the mask. So here we go. So it's setting up so that is basically setting up a blit, and I believe that's to actually draw the thing. And when you write to the blitter size there, that one, a write to that actually starts the blit. So we actually started a blit here, and I think we actually drew, oh, it does say draw a missile. We actually drew a missile there. So you think, well, that's cool, that's fine. Except you go down a bit now, and then it starts moving more data into the blitter. So straight away after doing that, it's starting to change the blitter values again underneath it. So yeah, on a 68,000, this might get stalled here because the blitter might have taken over the CPU. The CPU can run concurrently with the blitter if I remember, but it doesn't get every cycle. So that's a problem. And also, if the blitter is accessing chip RAM and the CPU then tries to access chip RAM, it's not going to be able to do it anyway. So it'll kind of get stalled. But on the setup that I've got, the code's in fast RAM and there's a CPU cache and it's running faster. So this blit's gone off on its merry way now. And then we're going to go and load something into, well, we're trying to load a value into chip RAM. Well, it's not chip RAM there, but it's the hardware register. So it might not be able to do that. But either way, it's going to try and start changing the blitter now. And it's starting to clear the blitter control there. And then it's setting up a different minterm there. This is the one, D equals A or B. So the destination equals A or B. Is this right? Is this the collision detection here? No, this is something else. I don't know what that one's doing. I don't know what that is. But there's 2 blits there anyway. So there's one, there's another. And then we start down here. So we've started the blitter off there. Now you can see here, like this clear word from the A0 register will be able to run while the blitter's going. So we start there. This will run. Moving something onto the stack, that's going to run too. Adding 16 to D1, that's going to run. So these are all going to be able to run, especially if the code's in fast RAM. These are going to be able to run while the blitter's going, if the CPU gets a chance, right? And then copying stuff around that could be in fast RAM as well. That could work. PF1 offset, I don't know what that is. Shift the scroll value. And here we go. So actually, from reading the comments there, use D equals is A and C. That's the thing I'm expecting. That's the minterm for the collision detection, I think. With D turned off. I don't know. It's saying does that turn D off? I don't know. And there we go. There's the A pointer. Move something onto the stack. So a lot of this can actually run while that blitz that started here is ongoing. And eventually, there we go. We start the blit there. So I think this is the collision detection here because it starts the blit, and then it bit tests DMA con R for bit 5 of DMA con R. Now that's not. This is the really annoying thing about this. That's not bit 5 of DMA con R. It's because it's big endian. This is like really horribly written. It's not bit testing bit 5. It's bit testing. Is it bit 12 or something? Let's have a look at DMA con R. Hang on. So this says DMA con and DMA con R. They are exactly the same, except one's a read only and the other one's a write one. So you'd think when it says test bit 5, you get 0, 1, 2, 3, 4, 5. So you're testing sprite DMA enable. No, you're not, because it's big endian. The word's big endian, and that means the big bits are stored first. So actually, it goes this. this byte is stored first. So if you take 0, 1, 2, 3, 4, 5, there we go. Blitter logic 0 status bit. That's the bit they said in the magazine that they'd be testing. B0 bit. But it's bit 13. It's not bit 5. This just reads really badly. So there we go. It's got rid of that sidebar. But yeah, there we are. So that reads pretty badly. But that is the test for the collision detection. So maybe it's just possible that after it starts that blit, that this can then execute before the blit's finished. And if that's the case, that's why the collision detection isn't working. And obviously there might be other problems here if these are doing actual writes to the screen. I don't know what the difference between these two is. That this one and this one are overwriting each other. But this here followed by this one line means that this bit test is actually not going to get the right bit, because then you're going to exit from draw missile. Where did we call this? Yeah, so you're going to exit from here and then you're going to immediately branch on not equal to 0 to update 2. So you're going to skip over the collision detection. So I think that's what's going on here, is that I don't know how you just got away with this on the, like, assuming this is the problem anyway. We're making the assumption that this is the problem. But I think you just got away with this on an A500 because you didn't have any fast RAM. Was it possible to get fast RAM in an A500? You could actually get fast RAM. So maybe this didn't work. We'd have to try that. If you got an A500 and put some fast RAM in it, I wonder if this would also fail. Because the code could get loaded into fast RAM and then maybe this instruction would execute too quick. But then you can just turn off fast RAM on an A500, so it would make the game work. A lot of memory accelerators came with the switch to just turn it off, and that was probably to fix things like this. I think we should try putting a blitter weight in this gap here, and then see if we get any kind of collision detection working. We might still have the screen corruption. Yeah, maybe this will work, but maybe it's still getting corrupted because it's got corruption from the previous blit from before. But that's my money's on that's what's gone on here, because we are running so super fast, just absolutely mega super fast. Yeah, so let's move over to the Amiga and then let's try and fix up some of this stuff. Well, let's test that out. Let's put the blit weight in there, see if we get anything. So we're back on the Amiga. We've got the code up and I've just assembled it. I'm just going to run it and make sure, yeah, it still works. Let's make sure we still got our problem with the collision detection, which we have, because currently I have to wait to die before I can get out. Oh, I can still see that corruption. There we go. Looked like I didn't hit anything there. Oh, do you know what? The graphical corruption that's being left behind, I think, let me just try this, is causing collision. If I go over that. Oh, no, it's not. Am I losing shield for going over this corruption? Yes, I am. Yeah, so when I go over that corruption, I lose shield. So the fact that the graphics are corrupting is actually corrupting the collision detection as well, because it's using that for the collisions. So that's interesting. So we have to fix the graphical corruption, otherwise the actual collision isn't going to work as well. Now, where was that bit of code that we needed to find? So I think we need to have a little bit of a wait here. Otherwise, we are in trouble. So actually, to wait, we want to, let's do wait collision. And we want a bit test. Now this is the funny thing, it's bit, what is it? It's bit 14, and they do it like this in the other bit 14 minus 8. I might make a macro to do this, because it's a pretty rubbish way of doing things. So it's actually that. Yeah, bit 14 is the blitter busy bit, and I'm subtracting 8 because it's big endian. Oh god, it's horrible. Wait, is that how we do it? I'm still a bit rusty at 68,000, so I can't remember if that's the right syntax. I think that's a blitter weight. We'll find out if it just crashes now. Oh, look at that. That's totally fixed it. Oh yeah. Oh look, I can get the power-ups now. I think though that this graphical corruption that's there, which is probably also caused by a blitter problem, The bullets are going to hit that, are they? Can't get it to hit one. Wow, I can actually play the game now. Well, that was a simple fix. It was just finding it. And whoever suggested that in the comments, I can't remember your name already. I'll put it on the screen. You are correct. Hey, look at that. 2-line bit of code, it's fixed it. But it does show that we're wasting time on the CPU now because we're having to wait for the blitter there, so we're just sitting around doing nothing. It'd be nice if the game could carry on and do something. That's a good start. But yeah, it's just a busy wait. But yeah, that just shows that we're wasting time here. We could be getting on with something else, but we're just sitting there waiting for the blitter. So that's not great, but it's a start. And if there's any more of these somewhere else, this might be the only one. This might be the only routine that does actually draw the missile, whether it's the cannons or whatever. If that's the case, that's fixed that. And we've probably got problems a bit like that in other places for the graphical corruption. So I think I'm going to wrap this episode up here because it's getting a bit long, but I'll just show you what I did. I wrote a little bit more code and just refactored what we had. I swapped out those couple of lines of code for a macro, which was blitter wait. I just called it blitter_wait because I figure I'm going to slap that around everywhere and I can just put blitter wait in hopefully, and that should do it. And that horrible bit test, I've swapped that out for a macro as well, which is bit test DMA_CONR, and I've actually used the names that are defined in the NDK for DMA bit blitter not 0, is that right? That's the result of the blitter not 0. And I'll show you the macros that I wrote for that, and I've just stuck them in this file. These will be in the GitHub as well here. So I have had to include a couple of files in this, hardware customite and the DMA bits. So there's my macro to do the bit test. So it's actually using the if, it's basically an if statement. It doesn't have an else and it doesn't have an end if, but this /1 is the parameter to this macro. So if I pass in bit 14, which is greater than 7, it will actually do what we did before. It'll subtract 8 from it and do it from the big endian bit, which is the byte, which is the first byte. And if it's less than or equal to 7, then it's the small end of the big endian byte. So it just does DMA_CONR plus 1. So there you go. So that looks a bit horrible, but all I have to do is write bit test and the actual name of the bit, and it just sorts out which one to put in for me. And the blitter wait macro, it took me a while to figure this one out because of this weird syntax here, which is the /at, and that just means generate me this thing here. Just means generate me a unique symbol here. So I'm generating a unique symbol to use as the label, and then a branch on not equal to that label if the actual bit of the blitter done, again -8 because it's a bit test with a byte, is in DMA_CONR. So that's just my wait for the blitter. I'm probably going to have to slap those everywhere because I've got the blitter wait there, but if you think about it, really, you've got 3 blits going on here, and according to what I've read, you shouldn't really be writing to these blitter the blitter registers until you know that blit's done. So ideally what you do is you do this like first blit here. When you write to blitter size there, that means it's going to start the blit, and then it straight away down here it starts writing to more blitter registers. So really it needs a wait there to be correct, and after this one it writes to the blitter size there, but after it doesn't use the blitter registers, it doesn't use them there, doesn't use them there, doesn't use them there, doesn't use them here, doesn't use them here, all there. So it only starts there. So you really want the blitter wait as late as you can, so that by the time you try and do that wait, you've actually done all these instructions maybe. We'll address those next time because I'm nearly there with this stuff, and we can start looking at the actual graphical corruptions. Yeah, there's no guarantee that these blits are actually done when you start the next one. You just, on the A500, they just were done. So that's where we're at. So I'm going to leave it there. This stuff's going to go into GitHub. Follow along for next time when we just start trying to fix more of this graphical corruption and get this at least this code back to where it should be, but working on A1200 with some fast RAM, with all the cache on, with the minimal amount of changes we need to get it to go, and so we can still keep all our speed that we've got from the having the cache on, but actually make the game work. So it's been quite interesting to do this. I imagine this is a common thing. I bet nobody waited for the blitter on the A500 because they didn't think to do it and didn't need to do it. So yeah, so this code getting patched. Right, I'll catch you in the next one.